So hello everyone, welcome back to Hasvora Education. Today we will be solving the hardest chemistry MCQs that have gone through the year 2024. I've compiled these questions myself, and these are only 15 questions. We'll be going over them slowly so that you can understand it properly because they are very unique questions and they test some very unique and interesting concepts. So make sure you watch till the end. So now without further ado, let's begin. The first question is: phosphorus reacts with concentrated sulfuric acid to produce phosphoric acid, sulfur dioxide and water. So A, B, C, D and E are the whole numbers. The equation can be balanced by using oxidation numbers. So what is the value of the sum of A plus B plus C plus D and plus E? So now first of all, what we are going to be doing is that we are going to balance this equation using the electron movement and the oxidation numbers. So how I attempt this question is, like, first of all you have to recognize the species that are going under oxidation and reduction. So first of all you can see the sulfuric acid, the sulfur in the sulfuric acid, the phosphorus and the sulfur. So these are actually going under the oxidation and reduction. So now what will I be doing here is, first of all let me zoom in. So now first of all you have to take the oxidation state of the sulfur in sulfuric acid. So +2 of the, let me just adjust the pen, so give me a second only. So this will be +2 of the hydrogen, then -2 into 4 of the oxygen, so it will become -8. -8 plus 2 is -6, so sulfur will be +6. So the sulfur is going, I'm just writing the sulfur so you can to avoid confusion. So sulfur is going from +6. Now we have to check the oxidation state of the sulfur in the SO2. So -2 into 4, it will be sorry, not -4, it is -2 into 2. It is -2 into 2, so it will become -4. So sulfur will be +4. So sulfur is going from +6 to +4. So it means it has gained 2 electrons. So you can just add the 2 electrons here. So sulfur +6 has gained 2 electrons to go to sulfur plus 4. So it is actually reduced. Now let's check for the phosphorus. Phosphorus is in the elemental form here, so it will be 0. And in the H3PO4 it will be +3 of the hydrogen, 3 hydrogen atoms, then -8 of the 2 into 4 oxygen atoms, and then let's subtract this. -8 plus 3 becomes -5, so phosphorus will be +5. Okay, so phosphorus is going from 0 to +5. This means it has loosed electrons. So you can either write it -5 electron here, but I will suggest that keep the sign of the electron same, like I have added it in the above reaction. So you have to shift it to the other side, so you actually add +5 electrons here. Okay, it will be minus here and +5 here. Now what we can see here is that the number of electrons are not balanced. So what we can do here is that we will multiply this by 2 and we will multiply this by 5. So the electron number actually becomes balanced. So this will become plus 10 electron plus 5 S plus 6. So S plus 6 was actually H2SO4. So now I can write 5 H2SO4. Then it is going to 5 SO2. Now in the second equation it will be 2P and then it is going to 2H3PO4 and plus 10 electrons. Now they are on the opposite side, one is on the reactant, the other one is on the product side, so it will be cancelled out. Now we can just write the whole equation as 5H2SO4 plus 2P because the reactants plus reactants. So and then on the product side it will be 5SO2 plus 2H3PO4. But we are not done yet, we have the H2O left out, so now we will just balance it. So there are 10 hydrogen on the reactant side, and on the product side we have 3 into 6, 3 into 2 is 6, so we will just add 2 here, so 2 into 2 is 4, 4 plus 6 is 10. Now we have the balanced equation, so this will be A H2SO4 plus B P and CSO, sorry, not CSO, it will be CH3PO4, H3PO4 plus DSO2 and plus EH2O. So the point is now you have to just add up the coefficients. So it will become 5 plus 2 plus 5 plus 2 plus 2. It becomes 5 plus 2 7, 7 plus 5 it becomes 12, 12 plus 2 is 14 and 14 plus 2 is 16, so this becomes 16. So D is the correct answer. So this is how you are going to be performing the balancing using the oxidation number. Now let's move on to the other question. Z is a gaseous hydrocarbon which has a density 3.50 into 10 power minus 3 gram per cm cube. So under the room conditions, so when it is a gaseous hydrocarbons, it means we can use the 1 mole is equal to 24 dm cube equation. Then Z reacts with an excess of hot concentrated KMnO4. Now can you just recall what this does? This breaks the double bond, carbon-carbon double bond in the alkene. So only one type of carboxylic acid is formed in this reaction. So what this actually means is that if only one type of carboxylic acid is formed, this means that the groups on the either side of the carbon atom, on the either side of the double bond, so they will be the same. That's why they will form the same type of carboxylic acid. And one more point, it will be it will have actually the, you can say, I will just say that it will have the same type of groups, so that's why it will form the same type of carboxylic acids. So now first of all what we have to do is we have to find the mass of the hydrocarbons. So how are we going to be finding the mass? You know density is equals to mass divided by volume. So 1 mole of this gaseous hydrocarbon will occupy 24 dm, so it will become density into volume is equals to mass, so this will become 3.5 into 10 power minus 3 into 24 dm. So they have given the density in how much, in the cm cube, so we have to convert this dm cube into cm cube, so this will become 24,000 cm cube. Now we get the answer as 84, so this will be 84 grams. So 1 mole of this compound will be actually 84 grams. Now what we have to do is we have to check the open structures of each of them. So this is butene, but2ene, so this will be butene. Let's just check. So it will have a hydrogen here, and the carbon here. So this group will actually form the carboxylic acid, and this will also form the carboxylic acid, and they will be same because they are the same groups. You can see CH and CH3, CH and CH3 on either side. Now we will just check its mass, so it will be C4 and it contains H8 because it is an alkene, so it will be 12 into 4 plus 8, so this becomes Let me just calculate. 12 into 4 plus 8, 56. So this will not be actually the correct answer because it does not validate the mass that we have found. So A will be eliminated. Now let's find 2,3-dimethyl butene. So this will be like this, butene and 2,3. Okay, so this will be 2 and this will be 3, and this is methyl. Now first of all, you can see here that there are two CH groups attached to the carbon, which is bonded by two double bonds. So this will actually form a ketone, not a carboxylic acid. So this will be eliminated right away. Now let's check for hextuene. This will be the double bond, and this will be the first bond, then 1, 2, 3 and 4. Now you can see here only one H is present, and there is only one H present here. But if you see here, what will actually happen is ethanoic acid will form here, because this double bond will form double bond O, and this will form OH. So ethanoic acid is forming here, while here on this side butanoic acid will form, because there are 4 number of carbon atoms. So this will form two type of carboxylic acids. So this is wrong. Now let me just clear up this space so I can do the last one. Now the last one is, let's just cancel out this. So last one is hexthreene. This will be the double bond, and 1 and then 2 on this side, and 1 and 2 on this side. Now you can see here one H is here and one H is here. These two will form the same type of carboxylic acid, propanoic acid, and let's also find out the mass. So it will be C6H12. So 12 into 6 plus 12, this comes out as 84 grams. So this just matches over mass as well. So the D will be the correct answer. Let's move on to the other question. It says 1 mole of each of the following 4 compounds is reacted separately with excess of sodium and an excess of sodium carbonate. So just before solving this question, I want to tell you one important thing that you need to keep in mind while solving these type of questions, that half mole of H2, or you can also say only one atom of hydrogen, reacts with one OH or hydroxyl group, and the same for, and actually not reacts, it is formed. Okay, it is formed. I was just a little bit confused. So it is only half mole or one atom of hydrogen is formed with one OH group when one sodium actually reacts with it, and half mole of CO2 formed with one carboxyl group. So now let's have a look. So which compound produces the same volume of gas with each of the two reagents? Now the A has two hydroxyl groups. It means one H atom will be formed with this, and one H atoms will be formed with this. So this will actually produce 1 mole of hydrogen. But if you see, they are actually telling us it will react separately with excess of sodium carbonate, while the hydroxyl group only reacts with the sodium metal. So this will be the wrong answer. Let's have a look at the B. So in the B, these two OH will actually react with the sodium and will produce 1 mole of H2, while this whole carboxyl group will react with the sodium carbonate. So what will actually happen is that it will form only half mole of CO2. So these are actually unequal, okay, unequal volume of the gases with the two reagents. So this will also be wrong. Now in the C you can see this is an aldehyde group. This will not react with the sodium carbonate, so you can just eliminate it, and this will only react with the sodium to produce hydrogen. So this will also be incorrect. Now in the D, if you see that the hydroxyl will react to produce only 1 mole of H2, and these whole carboxyl groups will react together to form 1 mole of CO2. So they are actually equal volume of gases. So this will be the D will be the answer for this question. Now 37 says which statement about PVC is correct. So now you can see that PVC has this structure. It is a polymer, so this will be like this. So this is how the polymer of PVC looks like. Now combustion produces products of PVC are very alkaline and harmful to breathe. So this is incorrect, because when you combust it, it produces HCl, which is very acidic, and indeed it is harmful to breathe in. But this will be incorrect because it is acidic, not alkaline. The empirical formula of PVC is the same as empirical formula of monomer. This is correct because the PVC is a polymer, so this N can be just divided by the number of molecules N, and this will give you the monomer. So this will be correct. Molecules of PVC are unsaturated. This is incorrect because it is a polymer. It contains no double bond. The monomer contains the double bond. So this will be incorrect. Then they have told the repeat unit of the PVC is CH2CCl2. So they are actually telling that this is the polymer, the monomer. So this is what they are trying to say. So now I have told you this is the structure, not this. It contains only one chloride, not two. So this will also be wrong. So now let's solve the next question. So it says 4 different alcohols are treated with alkaline iodine aqueous. Which row is correct? So they have provided us with the name of the alcohol and the formula of the products. So now we have to individually test out each of them. So let's begin with the A part. So butane 2-ol, so it will be like this. It will have a OH here, and this will be the structure. So now what will happen when it reacts with alkaline iodine? This part, the CH3 methyl group, will react with the iodine, and this forms a CHI3 triiodomethane, and this will become C2H5. This will become C2H5 and C double bond O and minus. So now they have shown that it becomes CH3 C double bond O minus. So this will be incorrect. And this the CH3 CI3, this is also incorrect. So A will be incorrect. Now let's see the B part. So it is propane 1-ol. So propane 1-ol. So this will be the structure of propane 1-ol. So now if you see, it does not have a, you can see it does not have a methyl group, so it will not react with the alkaline iodine. So this will be wrong. So the other one is the propane 2-ol. So propane 2-ol, this will be the structure. These two methyl can react, and if this one reacts, so it will form CHI3, and the other one will form CH3 COO minus 1. So now you can see these two products are correct for this one, so this can be the answer. Let's have a look at the last one. So this is, let me just do it here. So it will be butane 2-ol. This will be the structure. This methyl can react, so it will form CHI3 triiodomethane, and this will become C2H5, and together with C double bond O minus 1. So now what are they saying? Let me just check this. Okay, so this seems to be correct. This is actually correct. And okay, so what is actually the problem here is H3. It is not CH3, it is CHI3, triiodomethane. So this one is actually wrong. So D will be wrong. So C will be the answer. Let's move on. 29 says butene reacts with cold dilute KMnO4 to give product product X. So let's find out the product X first. So it is butene, okay? So butene. So now what will happen when it reacts with cold dilute KMnO4? This double bond will terminate. This will form OH here and OH here. So this is actually a dihydroxyl group compound. So then they have said that butene reacts with an excess of hot concentrated acidified KMnO4 to give product Y. So product Y will be actually like this, and this will terminate. This has H here, this has H here, so this will form carboxylic acid, which will be like this. Okay, so this is actually an ethanoic acid. Both of them will be ethanoic acid. So only one of the X and Y reacts with 2,4-dinitrophenyl hydrazine. So this point is actually incorrect because both of them do not react. 2,4-dinitrophenyl hydrazine has a reaction with ketone and the aldehydes. Now X and Y both react with sodium hydroxide. Sodium hydroxide is actually an alkali, so only carboxylic acid or the Y react. So this will also be incorrect. X and Y both react with sodium metal. Now this point is correct because the OH group and the carboxylic acid group, they react with the sodium metal. So this can be correct. Y reacts with LiAlH4 lithium aluminium hydride to give X. So if you see that if this is reduced, if this carboxylic acid is reduced, what will happen? That this will be reduced to this OH, and this will be something like this. So it actually does not resemble the product X. Okay, so this will also be incorrect. So C is the answer for this question. Now we have another question like we did before. W moles of HNO2 undergoes a disproportionation reaction to produce U moles of HNO3 and V moles of NO. No other nitrogen containing product is produced, and nitrogen is the only element oxidized or reduced. So just like I told you before, we are going to be doing the same. First of all, we are going to be making the uh, equation reaction. So let me first make a box. So this is the actually the reaction equation. Now HNO2 undergoes to produce HNO3 plus NO. So this is the V moles, this is the U moles, and this is the W moles. Now what we are going to be doing is, first of all we will find the oxidation state of HNO2. So +1 for the hydrogen, then nitrogen is left blank. -2 into 2 is -4, -4 plus 1 -3. So N will be equal to +3. Now HNO3, it will be +1 plus N -2 into 3, so -6 plus 1 is -5, and N will be equal to +5. And then for the NO, it is easy. It is n and then minus 2, so n will be equal to plus 2. Now we have to make the equation for them for just the electron movement. So what we can do is that the nitrogen with the plus 3 state is going to nitrogen with the plus 5 state. So if it is going from plus 3 to plus 5, it means it has lost 2 electrons. So you can also do like this, but I will recommend that you just keep it positive and you move it to the other side. So this will become plus 2 electrons here. Then the nitrogen plus 3 is also going to nitrogen plus 2. So this means it has gained 1 electron. So this will be plus 1 electron here. Now to balance this, we have to multiply this by 2. So this becomes 2 electrons plus 2, which was nitrogen plus 3. It was HNO3. No, actually it was HNO2. So HNO2, and then it goes to 2HNO3. Now we have to find out for the other one is balanced. Okay, it will be 2 actually, so it will become HNO2 and then going to HNO3 and then plus 2 electrons. So these two will be cancelled. Now you have just to add the product on the product side and reactant on the reactant side. So we can see a total of 3 moles of HNO2. So 3 moles of HNO2, and we also have, let me just count it. So it will actually become, I think we have done a mistake here. So let me just see. Okay, let me just see. Okay, so sorry, I have written here HNO3. This is not HNO3, it is NO. Let me just rewrite it. So this was actually NO. This one was NO. This one will be HNO3 and this one will be 2NO actually. Let me just remove this. So this one will be 2NO. So we got 3HNO, and HNO2 is going to 2NO plus HNO3. Now the moles of HNO3 were U, so it will be 1, 1, and the HNO2 were W, so it will be 3, and for the V it was 2, so it will be 2. So B will be the answer. This is how we are going to be doing this question. Let's move on. So this is actually a quite tricky question, and this also confused me at the first time. A structure for Borazole N3B3H6 is shown. Which shape is Borazole and how many pi electrons? Just focus on this word, not pi bonds. It is asking for the pi electrons and they're in the structure. So what will be the shape? You can see the boron is making 3 bonds. So I have told you the formula: steric number is equals to lone pair plus the bond pair. So there are only 3 bond pairs plus 0 lone pair, so it will be sp2 hybridization, just like the carbon in the alkene. So it will be 120 angle here. It will be trigonal planar. So there will be planar structure here, and they have asked about the number of pi electrons, not pi bonds. So you can see there is one pi bond, one pi bond, and one pi bond. So there are three pi bonds. But how many electrons are there in each bond? There are two electrons. So it will be 2 into 3, 6 pi electrons. So 6 will be the correct answer. Okay, so you have to be careful here. Now the other one says X is an impure sample of group 2 metal carbonate. So it is a group 2 metal carbonate, MCO3, and X contains 57% by mass of MCO3. So it means it has only 57% of the carbonate and the rest is impurities. So the impurities in X do not react with hydrochloric acid. 7.4 grams of X is reacted with the excess of hydrochloric acid. 0.05 mole of group 2 metal chloride is produced. What is the identity of group 2 metal? So let's first of all write the equation for this. So the MCO3 reacts with the HCl. This produces what? This is actually a carbonate plus acid reaction, so it will produce MCl2. Okay, the group 2 will have plus 2 charge and Cl is minus 1, so it will become MCl2 plus CO2 and plus H2O. Now if now we can just balance this. Okay, so we will just place 2 here, so 2 chlorides on the left, 2 chlorides on the right. Let's the number of hydrogens are balanced and also the number of carbons are balanced. So now we can just work out the moles. So they have told 0.05 mole is produced. So now if we just check that the molar ratio between the carbonate and the chloride is 1 to 1, so this will also be 0.05 mole. Now they have given us 7.4 gram of X is reacted and 57% of it is the carbonate. So let's check 57% into 7.4. How much is it? So 57 divided by 100 into 7.4, it becomes 4.218 grams. This means if we have any element from these options which have the 0.05 mole equal to this amount, it will be the correct answer. So now let's check for the magnesium. So magnesium is 24 into 0.05. Let's check how much it comes out. So this is actually a clever way of solving this type of question. So this is 1.2. So this is not even close, so it is wrong. The calcium is 40 into 0.05. It comes out to be 0.05 into 40. So it comes out to be how much? 2 grams. This is also wrong. Let's check for the strontium. So first of all, let me check the mass of the strontium. So the mass of the strontium is 88. So 88 into 0.05, it comes out to be how much? 88 into 0.05, it comes out to be 4.4 grams. So this actually seems to be correct and close to it. And now let's check it with the barium. So actually we have done a mistake here and I have realized it, that we are not going to be checking the metal actually. It is the metal carbonate. So let's check for the metal carbonate. The carbonate for the magnesium will be MgCO3. So 24 plus 12 plus 48 for the oxygen. It comes out to be 48 plus 12 plus 24. It will be 84. So let's find for the 0.05 into 84. This comes out to be how much? 84 into 0.05. So this is 4.2. This seems to be the correct one. Now let's check for the calcium carbonate. calcium carbonate is 40 plus 12 plus 48. So 88 plus 12 is 100 and 0.05 will be 5 grams here. So if you see the atomic mass AR of is increasing, so we do not need to check this one because it is increasing and the mass of the carbonate will also increase. So A will be the correct option, but you have to be careful here that they are not talking about the metal, they are talking about the metals carbonate. This is the thing I missed in the question actually at the first place. Now they are asking us about compound T has a skeletal formula. So they have shown you the skeletal formula, and which structure is shown the the is the structural isomer of compound T. So which structure shown is the structural isomer of T. Now what we have to do in these type of question is, first of all we have to count the number of carbons because they often do not keep the number of carbons same. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Let's count for the option A. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is 10 carbons. 10 carbons. So this is actually, this can be the option. Now 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has 9 carbons. This can't be correct. Now the C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This has 11 carbons. This can't be also correct. Now the last one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this also have 10 carbons. This can be the correct. Now we have to scrutinize between that A and D. Now let's first of all name this structure, the compound T. Okay, so first of all we will name this structure. Let me just remove this. So now if we start naming from the branch structure, it will be according to this. Let me just, this will be this second carbon here, this will be the one, the second one, then the third one, fourth one, fifth one, sixth one and the seventh one. So this is going to be the parent chain. Okay, this is going to be the parent chain. Now we will name the structure. So it is 1, it is 2 methyl, this is 2 methyl. Then we also have the on the third carbon, this is on the third carbon, this is the second one, then the fourth and the fifth carbon. So this will actually be equal to 5, 3, 2 trimethyl and 1, 2, 3, 4, 5, 6, 7 and pentane. So this will be 532 trimethyl pentane. Let's check the name for the A. So let's start the numbering from the branch structure. So it will be 1. Then the second carbon, you can see it also has the branch of methyl. Then the third carbon, then the fourth, then the fifth. It also has the branch. Then the sixth and the seventh. So this is essentially the same thing as the compound T. So this will be the wrong answer. This is not a isomer, it is identical to it. Now let's check for the D. It is 1, 2, it has the methyl chain on the second one, then the third one, then the fourth, then the fifth, then the sixth and the seventh. It also has on the third one, but it does not have a chain on the fifth one. So it will actually become 1, 2, 3, 4, 5, 6, 7 and it will be actually 3 ethyl, 2 methyl pentane. So this will actually be the isomer of it. So D will be the answer for this question. So always check for the number of carbons first and then for the naming, that is it the same or not. Now the other one says the molecule of the limonene C10H16 contains a six-membered ring. So six-membered ring means that it has a ring structure just like the benzene ring. This is only cyclic component in the structure. Okay, so this is the only cyclic component. There is not any other component like this. Which volume of the hydrogen at room condition is required to react completely with the carbon-carbon double bond in the one molecule of limonene? So first of all, you need to know that in the six-membered ring, we have six carbons actually. 1, 2, 3, 4, 5 and 6. This is the first carbon, second, third, fourth, fifth and sixth. Now we will complete the number of carbon atoms by drawing a structure like this. This is the 7th, this is the 8th, this is the ninth, and this is the 10th carbon atom. Let's count the number of hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it has how much? 20 hydrogen and 10 carbons. This structure that we have drawn. But they have told that it has 16 hydrogen. So one thing I want to tell you is that the ring structure, each ring structure removes two hydrogen atoms from the reduces to the hydrogen atoms number by 2, and each double bond also decreases 2 hydrogen atoms. So if we have to make this number 16 hydrogen carbon, we have to reduce 4 hydrogen, and we have to essentially make 2 double carbon bonds. So for example, if we make one here and one here, or you can also make it inside the ring structure, okay, so then it will become C10H16. So this contains 2 double carbon bonds. So now I have told you that when there is one carbon double bond, 1 mole of hydrogen is required to terminate this bond and add into it using the electrophilic addition. So this is how it will make so we actually require 1 mole of H2 for one double bond. So for two carbon double bonds we will require 2 mole of hydrogen, which is actually 24 dm into 2 and 48 dm cube. So this is a simple question, but you have to just visualize that what the question is actually asking us about. Now the other question that we have is the same as the oxidation states, but it is a bit different from that. So oxygen can be prepared by the reaction of potassium permanganate KMnO4 and hydrogen peroxide and sulfuric acid and H2SO4. So these are the reactants. So each H2O2 molecule, which is the hydrogen peroxide molecule, loses 2 electrons. This is another clue for the oxidation states. The other products of the reaction are potassium sulfate, then manganese 2 sulfate and water. So how many moles of oxygen gas are produced when 1 mole of KMnO4 reacts with an excess of hydrogen peroxide in acidic conditions? First of all, let's write the equation for this reaction, but it is not necessary to write it, okay? So by the reaction of potassium manganate KMnO4 plus H2O2 plus H2SO4, and it produces what? It produces oxygen, it produces water, and it also produces potassium sulfate and plus manganese sulfate MnSO4. So now the thing we are concerned is the manganese, because it goes from manganese from KMnO4 to manganese sulfate, and the other thing we are associated with is the hydrogen peroxide to oxygen. So now if you work out the oxidation state of the manganese in the KMnO4, it will come as +7, and in the manganese it will be +2. Okay, so they have already told you it is manganese 2 sulfate. Okay, and they have already provided you with the data that it loses 2 electrons and produces the uh, you can say it produces the oxygen, this whole reaction. So what we can do is that first of all we will form this equation H2O2, and this is actually losing, so you can also write -2 here, but I will write the +2 electron here. Now if you see, it also produces oxygen, because if you oxidize hydrogen peroxide, you will know for sure that it releases hydrogen and oxygen. Now we can see here that we have zero charge on the reactant side, we have a balanced charge on the reactant side, but on the product side we have -2 of charge because of the electrons, and we also have unbalanced number of hydrogen. We have 2 hydrogen on the reactant side, but we will balance this out by 2H plus ion. Why 2H plus ion? Because we have to also balance the charge. So -2 plus 2 becomes 0. So we have our first balanced equation for this reaction. Now what we will be doing is that we will look into the manganese. So manganese is going from +7. I'm just leaving space for the other reactants, okay, and it is going to +2. So it is going from +7 to +2. It means it has gained electrons, so +5 electrons here. So it has gained the electrons, that is why it is going from +7 to +2. So now what can we do is that we can see here that we do not have the number of charges balanced. So what we can do here is that we also know that we are producing the water here. So can we just write the water here? No, because it has the neutral charge. So first of all, how can we balance this reaction? Can you just suggest me anything that can balance this reaction? So what we will be doing here is that we know that there is +2 charge on the product side, so we will add +8 hydrogen here. So what it becomes? It becomes +7 +8, so and -5. So it will actually come out as, just calculate this, so +7 +8 and -5. So it comes out to be 10. Now we also have to introduce something on the other side. So it will become 4H2O to balance the number of hydrogen, and this will be the balanced equation for this reaction. Okay, so now first of all what we will doing is that we know that the Mn is actually +7, but the MnO4, it is actually minus. Okay, that is why we are adding this, because this actually is, I just wrote written the Mn +7, but it is actually MnO4 -1. Okay, so this is -1, then the +5, so it will become -6, and the +8, so it becomes actually +2. So we have balanced the number of charges. So now what we will be doing is that we have balanced the number of charges. Now we are going to be balancing the number of electrons. So we are going to be multiplying this by 2.5 here. Okay, so what will this reaction become? It will become 2.5 H2O2 plus, then we have the MnO4, or you can also write KMnO4. Okay, let me write KMnO4. Then we have the 8 plus hydrogen, then we have the plus 5 electrons. Then we have this 4H2O, and then plus the manganese plus 2, and then we have the 2.5 into 2 is 5 hydrogen atoms, and plus 2.5 of oxygen. So we can just cancel out the number of electrons. This will become 5 electrons. So can we balance out, cancel out these? Yes, we can. And now you can see that 1 mole of this KMnO4 is producing 2.5 mole of oxygen. So hope you understand this question, because it requires very much working. It is a bit advanced than the normal oxidation questions, like I showed you before. So now let's move on to this question. 14 says graph can be drawn to show the percentage of ammonia at equilibrium when nitrogen and hydrogen are mixed at different temperature and pressure. So now the thing you need to know about to solve this question is about the Haber process and the reaction of hydrogen and nitrogen to produce the ammonia. So the thing we need to know is that hydrogen plus nitrogen produces what? NH3. This is half mole and this is 3 by 2 moles. Okay, so and this is actually a negative enthalpy reaction, like it is an exothermic reaction. So for the exothermic reaction, we know yield is favored at low temperature. Like when we increase the temperature, the yield will decrease. And you also know that if we just balance out this reaction, if we just simplify it, okay, no need to deal with the fractions, just multiply it by 2, so it will become 3H2 plus N2 and 2NH3. So you can see that we have 4 moles here and we have 2 moles here. We increase the pressure, it moves forward. So increasing the pressure increases the yield. This is the yield, okay, the on the y-axis they have given the yield. So if we increase the pressure, the yield is gonna increase, and if we decrease the temperature, the yield is also gonna increase. So the yield is going to be more at the 400 Celsius. Okay, it is going to be more at the 400 Celsius. So and at the 500 Celsius it is going to be less. But how do we know whether it is going to be upwards like this or it is going to be downwards like this? The thing I want you to know is that the yield of the ammonia is actually how much. If we do the reaction at the 400 Celsius and the pressure, it is actually 17.6%. This is the maximum yield that can be achieved at the factory stage. So it is going to be lower than the 40 mark. So it is actually going to be decreasing. And if we are actually increasing the pressure, so it is going to be increasing, and it is going to be you can say, and if we increase the pressure it is gonna decrease. So 500 Celsius is going to be having a less yield than the 400 Celsius, and increasing the pressure will increase the yield. But this will be the answer. D will be the answer. Okay, you actually do not need to know this, and this is not actually useful, but I was just telling you that this is the maximum yield that can be achieved. So D will be the answer for this question. Now this is one of the most interesting, and you can say the difficult questions, because it tests a concept that has not been taught to many of the students. So structure isomerism and stereoisomerism should be taken into account when answering the question. The structure of 3-methyl cyclobutene is shown. So this is like a cyclic structure. So a mixture containing all the stereoisomers of 3-methyl cyclobutene is treated with HBr. This produces a mixture of isomeric bromomethyl cyclobutanes. How many stereoisomers does 3-methyl cyclobutene have, and how many isomeric structures does bromomethyl cyclobutanes are present in the product mixture. So the first thing I will like you to know is that in the cyclic structure, the geometrical structures isomers like the cis trans don't exist in this structure. Why? Because if you see, the hydrogen is here, and here we have the CH, and on the other side if you have a look at it, here we also have the H, and here we have the CH2. So in the cyclic structure, the cis trans actually don't exist. So let me just remove this first. So the cis trans don't exist. Let me write this point: cis trans don't exist in cyclic structure. Now if you see this carbon, it has been bonded to CH3 like this, and it has been bonded to this upper cyclic structure, and then we have the CH2, and this is actually the CH2 here, and this is also been bonded to a hydrogen. So you can see that it is actually a chiral carbon. So it will have an optical isomer. So from this we actually have two isomers. So we will just circle this one first. Now it is reacting with the HBr. So if we react this structure with HBr, what can actually happen is that HBr can either bond on this side, or it can be like this. Okay, it can also be like this. So now if you notice, if the HBr is bonded here, it will also form a chiral carbon because it has the bromine here, the CH here, and there will also be a CH here. So it is actually bonded to four different type of groups here, and it will actually form a optical isomer. So we have the not two, we will have two isomers because of this, two optical isomers because of this. And the other thing that we will have here is that in the case if it is bonded like this, what will actually happen is that the CH3 will be below and there will be hydrogen here. But in the case, what happens if the you can say, let me just try to explain it. So in the case if the CH is above, the CH3 will be acting downwards, so it will be like this, and it will actually form a cyclic structure like this, and it is the Br is facing downwards. So what actually happens in this type of structures is that in the single bonds it also forms the cis trans. So if the CH3 and you can say the Br are actually opposite to each other, like CH3 is below the ring and the Br is above the ring, it will form a transversion. And if it is one is above the ring and the other is below the ring, and the other is also above the ring, it will form a cis structure. So this actually forms a cis and trans. So now we have one optical isomer, and we also have the, you can say, uh, we also have the cis and trans version of this. So how many isomers will it actually form? So let me just count it. So this will become 1 and 2, and then we also have this chiral carbon as well here. So it will actually be equal to 2 power n. So 2 power 2 is equals to 4. So 4 isomers because of this and 2 because of this, so it will actually be equal to 6. So B will be the correct answer. And this is actually a very unique point here, that the cis trans also exist in the single bond in the cyclic structure where there are no double bonds, because most of the students do not know this point. Now we have the relative atomic mass of antimony is 121.76. Antimony has two isotopes. The mass number of the two isotopes differ by 2. So this is the important point here. The isotope with the lower mass number is more abundant. So I want you to know that if it is more abundant, if for example if the lower isotope is 121 and the higher isotope is 123, it is differing by 2, okay? So if the lower mass is more abundant, it means that it will actually be just close to 121.76, which is the relative atomic mass. So that is why it is more abundant. It will be close to the lower isotope, and it is also you can say more abundant, so the other one will have less percentage of it. So first of all, what we will doing is that we will take the percentage abundance of the SB as 121 as 100 minus X, because it will be subtracted from the other abundance, and SB 123 will actually be equal to X. So let's find it out. So it will be 121 into 100 minus X, as it is a percentage, it will be divided by 100, plus then we have the 123 into X, and this will be 100, and this is actually equal to 121.76. You just need to solve this. So take the LCM of the 100. It is also already 100, so it will be just multiplied there. It will be 121, and then we have 76 here, and this will become 12100 minus 121x, and for the other one it will become 123x. So this will actually be the you can say the equation that formed at the end. So let's just calculate this. This will become 2x plus 12100 actually equals to 12176. 2x is equals to, just subtract these two, it will become 76, and x is equals to 38%. Even if it comes higher, like the if you if we just do the reverse, 100 minus x, okay, if we had taken 100 minus x for 23, if it would have come like, you can say it would have come like 62%. But you know that the lower mass have a higher percentage, so the other one will have lower than it. So this will be for this one will be for sure for the lower mass isotope. So this one will be for the higher one, and they are actually asking us about the higher, so this will be B. So these were all the questions. We have just completed the worksheet. Also, I will be attaching this worksheet in the description down below. So share this video with anyone you think it will help in the paper, and I'll be meeting you in another video. Till then, goodbye.